Good afternoon, everyone. My name is Yvette McKenna. I'm the Water Management Division Manager here at Reclamation in Albuquerque. This is the annual operating plan for the Pecos River, and we wanted to just go back and look at 2023 and see how we did with our models and predicting what the stream flows might look like out of the Pecos, and also some reservoir conditions. And we're also going to take a look at 2024 and give you the best information that we have going forward with inputs from our partner agencies and also our stakeholders, including the project beneficiaries like Carlsbad Irrigation District and Fort Sumner Irrigation District. So we really appreciate everyone's accelerated communication with us. It's been a really good effort to just make this the best information available and possible. And we look forward to a good runoff and a good irrigation season for you all. And if you have any questions, please just give us some feedback and let us know. I'm going to turn it over to Carolyn Donnelly, and we also have some logistics from Michelle Estrada Lopez. Thank you.
Good afternoon, everybody. It takes me a while to come up to the camera area. Just wanted to let folks know, let's see, we have 3 presentations this afternoon. First, we'll have Gus Goodbody from the Natural Resources Conservation Service discussing the new streamflow forecast model that they're using. And then we'll go to Andrew Mangum from the National Weather Service, who's going to give us a climate outlook for this year and hopefully some good news. And then Reclamation will present some results for their annual operating plan runs that were done in conjunction with the Corps for the reservoirs that the Corps and Reclamation operate for the Carlsbad Irrigation District and generally the Pecos River Basin in New Mexico. And since there's really nobody here in the room, if you have questions, you can type them in, but we are going to hold all questions. We may ask, if you have questions during, or say Gus or Andrew, we'll probably ask those after each individual's presentation. And we are going to record the meeting. And anything else, Michelle? Thanks so much, and thanks for coming, Andrew, and thanks for helping us out with helping us learn more about your model, Gus. And with that, we can turn it over to Gus.
Hi there. Thanks very much. Good afternoon, everybody. I'm going to share my screen here. Just give me one sec. Okay, I think I'm good to go there. Yeah, again, thanks for the introduction, Carolyn. I'm Gus Goodbody with the NRCS. I've been a lead forecaster for the NRCS in the Rio Grande for several years, since 2008. And I am just turning those duties over this year to Carl Wetlaufer, who's a new forecaster on our staff. You'll be in excellent hands with him. And I'm going to talk today a little bit about a new modeling system that we've introduced this year, and see if we have any questions. But yeah, I'll just jump right into that. So I'm going to start by saying that our new system, which we call M4, is really the modeling system. Persephone is the forecast environment. So we think of it like Persephone is really the UI that the forecasters interact with, and M4 is really the modeling structure that that is implemented through that system. This is a project that's been underway for several years with the NRCS. It's been a very deliberate process in terms of identifying, what our needs really are and matching a new system with those needs. This slide's really just getting at the point that there's a lot of different paths you can take to water supply forecasting. And, we've landed on this multi-model statistical and machine learning method because it intersects really with what we're able to do and what our stakeholders really need, and also represented a gap in the in the water supply modeling that existed. So I'm going to move on to the next slide. Just key points about M4. So it's a pretty big change for us in the sense that we're going from a single principal component regression model as the basis for our water supply forecasts to 6 independent machine learning techniques. So this involves actually training and executing, 6 times as many models as we've been used to doing in the past. The other piece about it, it's similar in some ways to our legacy system in that we still use a data dimensionality reduction step right at the beginning. That's principal component analysis, where we feed all of our input data into that analysis, and it reduces the signals from those data basically into the primary modes of variability, and that's ultimately what's used in the model to predict the runoff. There are 2 uncertainty estimation techniques that are used. One is traditional conventional that we've used for many years, which is just assumes a normal distribution of the data, and so we can actually pull the different exceedance probabilities off of that curve based on that assumption. The new aspect to the system regarding uncertainty estimation is the use of a Box-Cox transformation, which is better in nonlinear system or non-normally distributed systems, which definitely exists throughout the Rio Grande in places. It also performs well in linear systems too. So that's or normally distributed systems. So that's a nice one-stop shop way for us to estimate uncertainty for both of those different types of systems. The genetic algorithm is my next bullet point. So this is a new way for us to help optimize what input variables we put into each of our 6 models. Basically, we select the input variables, and for now, they're typically really similar to what we've done historically, which is to use current snowpack data from our SNOTEL network that's in the basin of interest. We also use water year precipitation, and in some cases, antecedent stream flow. We throw all of those variables that are available from the different sites into the candidate predictor pool, and we let the genetic algorithm work its way through and find the optimal combination of those predictors. That results in the highest skill model that can be made from those different variables. That step is followed for each of our 6 independent machine learning techniques. So you can actually end up with different input variables for the different techniques. And then finally, we bring the results from the 6 independent techniques together using a very simple ensemble mean approach. So at the end of the calculation of the forecast and uncertainty for each of the 6 independent techniques, we basically just take the mean of each of those exceedance probabilities from the 6 techniques, and that's ultimately what the final forecast is. Main reason for doing that is to address the question of equifinality, which has to do with knowing which model is actually going to perform better on any given year, and usually we are not able to do that in advance. So Persephone is the user interface, like I mentioned before. This is really where we interact as forecasters with the system. This is our new forecasting environment for water supply forecasting at the USDA, and it's a web application and user interface. Really, it's the Persephone side of it is to organize and automate modeling and forecasting processes. So I mentioned that the new system really represents a change for us in the sense that we're generating much more model guidance than previous. Our staff has not really grown, so we've got to find ways to do that through technology. And so that's the automation of some of the modeling steps. I mentioned this a little bit already, but basically the workflow is to select candidate predictor variables, and we have some nice map-based tools to help us do that. So for the Pecos, for instance, we would go in, look at the sites that are, in or near the basin, select those sites, decide which actual elements we want to be considered. And again, that's usually snow water equivalent measurements and water year precipitation. And then that becomes our candidate predictor pool. Persephone also then connects to the data sources. So this allows the gathering of the actual data from all the years in the historic record that are needed to train the model. It goes and connects to our databases at NRCS to do that, and it formats that information into input files, which are then connected to what we call the M4 service. So M4 is the actual model, and it lives in a software as a service setup. So basically we can feed the input files to that service. It does all the computing, and with these 6 different models, some of them actually require pretty extensive compute times. So it's pretty different from our legacy models that essentially we can generate model results almost instantaneously. In some cases, we can wait 15 to 30 minutes for all of the computations to be completed, at which point the output from those are returned to Persephone, and we can use the display and visualization tools there to review the model training and decide if we got satisfactory results, or if we need to make small changes to the ensemble members that will be used for the official forecast. That's the moment where that happens. So what will Persephone empower? I've already mentioned it improves our model management through process automation. As a reminder, we're not only doing forecasts for the Pecos and Rio Grande, but the NRCS is in the business of doing water supply forecasts across the Western US and Alaska. We have about 600 different forecast points total in that domain. So a lot of our work actually just becomes a scaling issue. How can we provide high quality guidance for a wide variety of points? So some of this automation we're excited about for a bunch of reasons, but there's a few of them listed here. We'll be able to recalibrate our models more frequently than before. So we'll be able to use the most recent data from the most recent years in our actual model training. And we'll also likely be able to issue more frequent updates. So currently we issue 1 forecast per month in the winter from January through May or sometimes June. And we are moving towards a model where we would be issuing guidance, if not daily, at least weekly frequency and updates. And a lot of this automation too, it leaves more time for the individual forecast hydrologist to do more interpretation of the model results, and add value to ultimately to the forecast, as opposed to just spending time on the mechanics of running the model itself. We consider this new system basically represents an incremental improvement in forecast model skill. There's a lot of things about the way it behaves that are very similar to our legacy system. But what our testing has shown is that more or less across the board, and I'll show this in the next slide, we've actually seen very modest but incremental gains in model skill across a variety of domains. And finally, really this new system will also serve as a platform for additional testing of new methods and input variables. So this is really just the beginning of, for us for exploring further ways to improve model skill. So here's just a few charts, not to get too wrapped up in this, but these results are from different important forecast points across not just the Rio Grande, but the Colorado Basin and also the Great Basin in Nevada and Eastern California as well. These are for April 1 forecasts, and the main takeaway here, these are looking at 3 different model skill metrics. So the first one on the left is just a R squared. So this is basically how well do the model input variables correlate with the stream flow that we're trying to predict. In all of these charts, the orange line represents the results from the new M4 Persephone system, and the blue line represents skill metrics from our as issued historic forecasts. So in the case of R squared, the orange line you can see is generally above the blue line. That's the direction we want to see for improvement. In the middle plot, we're looking at root mean square error, which is basically an average error that you'd expect. In this case, we want that to be as small as possible. More skillful models will have smaller root mean square errors. And again, in this case, the orange line, which represents the new system, is below the blue line, which is the positive direction for improvement. And then finally, the maximum error chart on the right. This perhaps is the most noticeable and where the largest gains were made. We want to reduce the maximum error from any given year as much as possible. And that's represented here. Again, the orange line is the M4 system, so those values are typically smaller than the blue line, which represents our historical metrics. Additional benefits of the system, I mentioned the ensemble mean. In addition to dealing with the situation of where it can be very difficult to choose which model to use on any given year, what we see in our calibration and testing results is that most often combining the forecast together actually improves the overall skill compared to any individual model or any individual ensemble member. This is pretty remarkable and a little trick that we stole from the meteorology community. And so far it's been quite impressive that even when individual models may have, R squareds of 0.8, you can actually end up with an ensemble that is higher skilled than that. This multi-model approach really insulates against individual model vulnerabilities on any particular year. And again, it can be difficult to estimate which model may struggle on any given year. So this is a way of dealing with that issue. It also allows models, any model that can be significantly better in under certain conditions to be used in a forecast. And again, it can be difficult to know ahead of time or during the forecast season which model is going to perform better at the end of the year. Also offers a potential to add additional methods to the ensemble, and this could be external forecasts such as from our partners at NOAA, the West Gulf River Forecast Center, who provides ESP forecasts for many of these same basins. It also provides an opportunity to continue to introduce new machine learning techniques that we would run on our side as well. And just a note on stability during this transitional year. So there's definitely a lot of new things about the new system, but there's also a lot of common pieces that are shared between the old and new system. First and foremost, the model predictors. So these are the variables that we actually use to predict stream flow. Again, these are largely coming from our SNOTEL sites and manually measured snow courses that measure snow water equivalent precipitation, as well as antecedent stream flow in some cases. That basically matches what we've used historically. So we're forcing the models with more or less the same input variables as in past years. Additionally, the legacy method, the principal component regression model, which has been the basis and foundation for our forecasting since the early 1990s, and really similar to our approach all the way back to the 1930s, is still one of the ensemble members. So it's one of the 6 default techniques in M4. And finally, the reporting and interpretation of the forecast is no different than in previous years. So we publish a best estimate, which is usually the 50th 50% exceedance probability, and then our forecasts are always published as probabilistic forecasts due to the general uncertainty of these types of forecasts. And just to close out, didn't spend a lot of time on like the super rigorous details of the modeling system. We do have 2 great papers that have been published, peer-reviewed. You can access them through this link here on our webpage if you're interested in more of the nuts and bolts details of how these systems actually work. And with that, I'd be happy to take any questions if people have them.
Thanks, Gus. Online, if you have any questions, just type them in and I'll be able to read them out for you. In the room, is there any questions?
It might just be worth noting, based on the question this morning, that this is implemented this year.
Thank you, then. All right, if you think of something later, feel free to type in your question and we'll try and answer it later in the presentation. So we're gonna switch over to back in the room with Andrew. Share your screen.
Well, it's not shared. Oh, sorry. I'm just on the display, not the.
Bear with us one moment, folks. There we go. There we go. Perfect.
We're live.
All right, is that shared now successfully?
Just a moment. It should be now.
Okay. Just me, it's a little bit blurry.
I think it, oh, it's everywhere, huh?
It wasn't blurry.
It wasn't blurry until we shared it.
Oh,
Try again.
maybe just don't do
Let me
it.
try closing and reopening real quick.
Okay. Crystal clear. Love it. Thank you. All right, good afternoon, everyone in the room and online. My name is Andrew Mangum. I'm a senior service hydrologist for the Weather Forecast Office here in Albuquerque with the National Weather Service. Today, I'm going to talk to you about the monsoon and water supply outlook for the Pecos River area. This is going to include a review of precipitation over the last year, what our snowpack looks like currently up there, some discussion of drought conditions, soil conditions. Then we'll get into a climate outlook, and finally, I'll finish off with what the River Forecast Center and the National Weather Service is thinking about the water supply forecasts for the Pecos River. All right, so starting off with total precipitation for last year, we really didn't have very much. We came out last spring, we came out of an absolute bumper crop of a winter with unbelievable snowpack, in some areas record snowpack in the state, and it was a really good water supply spring, really strong runoff. We had flooding impacts, which was an unfortunate side effect of all that, but it put us on some really good footing, and then we did not get a monsoon season really to speak of. Over and over again, we had a high pressure system set up right over the central part of the state and kind of act as a buffer for any storm systems that would try to intrude into New Mexico and deliver any moisture. Instead, they just sort of went around us over and over again. So as you look here at this map, you can look at the absolute amounts of precipitation on the left, but really what's important to look at is this percent of normal precipitation on the right, where we are well below normal in most of the state. There were a couple of areas that did okay, but they were really, really small areas of the state. Overwhelmingly, the state kind of was below average for precipitation for the whole year. That's shown here. This is a slightly harder to look at map, but this is also past year precipitation as a percent of normal. The state lines aren't quite as crisp on this one, but it's a similar kind of story. There are a couple of areas where radar indicates that there was a decent amount of precipitation over the last year, but by and large, the state is running well behind. This is in contrast to the previous year, where we did have that lovely spring and runoff, but that itself came after one of the best monsoon seasons the state has seen in a long, long time. And that's shown here. This is the previous year's percent of normal precipitation. And you can see that really strong monsoon in the sort of the western half of the state. Now then, looking at our snowfall analysis for the year, we will talk about SNOTEL data as well, the kind of data that gets used by the NRCS and that we use as well. What I'm showing you right here is not SNOTEL data. It incorporates it to a certain extent. This is SNODAS. This is our modeled snow accumulation for the year. And so this incorporates data from radar, data from observation reports that we get called in, flight lines to measure the snow, things like that. So it's kind of a multi-platform measurement of snow. And this is showing seasonal snowfall in inches for the area. And we see a broad swath in the northern kind of half of the state of 12 to 24, going up to much, much higher in the high mountains where we have 120 to 180 inches of snow and beyond up there, 240, 360 inches of snow in some spots for the whole season. Those really high-end amounts are confined to kind of a few locations, but overall, not a bad season up north. The distribution of the season was kind of interesting. It was a slow start to winter. I think we all remember that. We had a pretty dry December, pretty dry January, pretty lackluster first couple weeks of February even. And it really wasn't until sort of the latter half of February through March that things turned around and we started really developing a decent snowpack up in the mountain. And that is what has put us in the position we are in right now. So taking a look right here at the snow water equivalent over the Pecos headwaters, again, this is SNODAS. You're looking here at an area where in terms of inches of liquid water present there in that snow, we're seeing a whole kind of swath there of 10 to 12 inches of liquid water. But notably, further up into the mountains there, we get up into 18 to 20 to 20 to 30 inches of water ready to come down into the river. So that's what the River Forecast Center is using when they are doing their forecasts. We model the melt out of that much snow. I wanted to touch on that. We can also turn and look at the SNOTEL. And so what we're seeing here is the snow water equivalent from the 3 SNOTEL stations that are there in the upper Pecos Headwaters Basin. The black line that you see running through that is unfinished, that is the 2024 accumulation. That green line that's sort of halfway down running through the center of everything, that is the median for the last 30 years from 1991 to 2020. And this darker blue line represents last year's snowpack, which was pretty good in the Pecos, not as strong as other parts of the state, but still not bad. We're a bit below last year now. We did actually beat out last year and for most of the winter in terms of accumulation. So it's a decent amount of snow up there. But right now we're sitting here, the SNOTEL is saying that we're currently just above 10 inches of SWE. So that kind of corresponds pretty well with the ring that we're seeing at the lower end amounts. It's the SNOTEL stations aren't really capturing those high end amounts that are suggested by SNODAS. If we take a look at our drought conditions, last year we were really optimistic, right? Because we had this great snowpack, really good spring runoff season, and the drought had really improved through large areas of the state, certainly throughout the entire Rio Grande and Pecos watersheds. This year is not really the case. Because we had such a dry summer and fall, the drought conditions are substantially worse throughout much of the state. And the Pecos River, which runs along here towards the eastern edge of this watershed, it actually passes through the very worst drought, the exceptional drought conditions down there in southeastern New Mexico. So that's something to keep in mind when we think about water demand down there, that this is one of the hardest hit parts of the state that the Pecos is trying to serve. We take a look at soil conditions. This is last year, so this is 2023, and there's 2 different things being shown here. This is a satellite-based soil moisture product that we use here at the Weather Service. And on the left hand, you're seeing the 1-year change in the soil column of relative soil moisture. And you can see here that from 2022 to 2023, the change represented a massive amount of wettening of the state, right? And that's what we got from having a really good monsoon in the western half of the state that I showed earlier. And that's what we got from having a pretty good winter. We had really wet soils. And if we just look at the soil moisture percentile on April 17th of 2023, you can see that the ground was really quite wet through like the western 2/3 of the state. It was really good soil. Now, it also helped with our runoff conditions. It promoted a little bit more water being delivered to the channel rather than being infiltrated into the dry soils. This year, it's an interesting and slightly contradictory message, right? We have this 1-year difference, and it looks like the entire state went dry. And it kind of did compared to where we were at this time in April last year. We saw quite a bit of drying out through the whole area. However, this picture on the right here is showing fairly wet soils in the, the northwest and north central. It's important to take a look at these and understand that they're telling us different things, right? Like this is talking about the change throughout the course of the year. And on the right, what we're looking at is a snapshot of the soils right now, which is actually the most relevant for what we care about, right? The late snows and the late rounds of precipitation we've had have wetted those soils up right up there. And that's going to help us with runoff, especially right here over the Pecos area, where those headwaters are in one of the wetter parts of the state. So that should promote runoff pretty well from the snowpack that we have up there. Looking ahead now at the climate, back in January, we had started discussing the CPC, the Climate Prediction Center, had started forecasting an abrupt transition from El Nino conditions to La Nina conditions. That is definitely the case. We are biting down hard on that forecast. And it looks like sometime in the June, July, August timeframe, so right there during the peak monsoon season, we will be making a severe switch in ocean temperatures that will put us right into La Nina conditions. And it's a very, very fast transition. We're just talking about a couple of months to go from warmer than average ocean temperatures to cooler than average ocean temperatures, right? What does this mean for New Mexico? For the monsoon, there isn't really a very strong correlation between La Nina and El Nino and monsoon performance. There is a much stronger correlation between El Nino and La Nina and winter performance, right? So La Ninas typically indicate a drier, hotter winter than usual. Not always. We were in a La Nina winter last year and we ended up getting a kind of record snowpack, but it was a very unusual and strange La Nina. It was the third La Nina in a row, and those are almost unprecedented. So we don't always have a good sense of how that is going to impact these things. And it's always important to say that when I say typically La Nina is warmer and drier, that's not a lock, right? That doesn't guarantee it. It just loads the dice towards a drier, hotter winter than usual, right? So that's what we're worried about here. Now then, we're thinking about this for the winter, but we do need to think about what's going to happen with the summer in terms of water supply. And if we look at the Climate Prediction Center's outlooks, starting off with the outlook for April, there really wasn't a clear signal. It was equal chances of above, near, or below normal temperatures and equal chances of above, near, or below normal precipitation amounts for most of the state for April. As it turned out, we were a little bit below normal for precip and a little bit above normal for temperatures so far in April, but we're not quite done with it yet, so we'll give it some time to see how it pans out near the end. Now then, for the looking ahead to April, May, and June, we're starting to see the Climate Prediction Center lean hard into a very La Nina looking kind of forecast where everything's going to be hotter and drier. We're seeing a clear indication of above normal temperatures and stronger chances for below normal precipitation from April through June. We're also then seeing those signals get stronger as we move through May, June, and July. We're seeing there a quite strong, like 60 to 70% chance that will be above normal temperatures and a 50 to 60% chance that will be below normal precip there. So in the likely, below, likely, low categories there. Moving ahead through June, July, August, that signal just keeps getting stronger, right? So they're just biting down very, very hard on this idea that the entire summer, the entire monsoon season is going to be hotter and drier than average. They may be right. I'm not going to sugarcoat that. That could happen. However, we have, I'll go back to that slide in a second. In our office, we have some people who specialize quite extensively in climate research and pay a lot of attention to these sort of trends. And we have some different thinking going on in our office. We're looking at an unusual event, and the unusual event in question is this abrupt change during the early summer from El Nino to La Nina. And when that happens, and especially when it is correlated with certain other oscillations that are out there in the climate, you can have some interesting effects happen with the jet stream that will prevent things like really hot, dry air intruding into the state during the monsoon season, which is what we suffered through last summer, where we had hot, dry air come in and just sit over the state. The thinking in our office is currently that what we have seen in 2010 on the left and 2015 on the right, where we also had these abrupt transitions, was that we actually got in 2010 a slightly above average monsoon through almost the entire state. And in 2015, it was a little hit and miss. We had some areas that were just a little bit under, but some areas that were just a little bit over. So overall, not a bad monsoon in either one of those years. And both of those years were also predicted to be hot and dry by the CPC. So our thinking is, our best thinking is that probably what's going to happen is that we're going to get a late start to the monsoon. We're going to probably see a pretty dry June, and we're going to probably see a pretty dry first half of July. But our best thinking is that near the end of July, things are going to turn around, and we're going to start getting a fair amount of moisture coming in from July through the beginning of September, enough so that it might help us catch up and near an average monsoon season in terms of precipitation amounts for the state. That's not a guarantee. There's an enormous amount of uncertainty that goes into forecasting the monsoon. It's extremely hard to even forecast kind of roughly, is this going to be a better or worse monsoon than usual? It's right next to impossible to say it's going to be a really good monsoon right over the Pecos headwaters. But this is our best thinking. In terms of what the drought monitor and the drought outlook is saying, the best thinking from the CPC at this point is because it's going to stay kind of hot and dry through the summer, the areas that are in drought are going to stay there. It's interestingly, they don't call for a bunch of drought development in the West, but that's where they're at right now. We'll see if that changes as they move forward. Now then, let's get into our water supply forecast. And it's worth taking a minute to walk through this graph and really understand what it means, because it is a complicated graph. So first off, what are we forecasting here? We're forecasting the volume of water in thousands of acre feet that should pass through this point, the Pecos River near Pecos, from the beginning of March through the beginning of August, right? And any point on this graph that I point to is saying, like if I point here at December 1st, it's saying that roughly 30,000 acre feet is forecast to pass through that point from March 1st to August 1st. That changes as the winter develops. And so here we are now, here's our April 1st forecast, and the April 1st forecast is close to 53,000 acre feet. Right, passing through that area. March 1st forecast was a little bit lower, kind of more like 35,000 acre feet going. So I wanted to make sure that part was clear to everyone. Now let's talk about all the rest of the bells and whistles on this page. You've got this max flow, and the year that it happened, 1941, was 154,000 acre feet. You've got a min flow in the year that it happened, which was 2018, 8,000 acre feet. You've got this forecast window. This is the window through which that volume is supposed to be delivered. You've got your median, you've got your average, and then you've got this shaded graph through here. That dark blue line is the 50% exceedance probability. This is sort of what our official forecast is going to be. There's a 50-50 chance that you're going to see more water than that, or less, all right? The bottom of that shaded area is our 90% exceedance probability. There's a 90% chance you're going to see more water than is at the bottom of this. And the top of that graph is our 10% chance. There's only a 10% chance you're going to see more water than is at the top of this graph. These vertical bars with these dark spots in them, these are the official NRCS forecasts, and that center point is their 50% forecast, which has been pretty close to average for this point through the entire season. So overall, that's the layout. We're going to walk through a few points. But let me just start by saying up here, the first gauge up near the headwaters of the Pecos, we're forecasting a near average water supply year in terms of volume that's going to go through that point. Interestingly, throughout most of the Pecos, there's quite a bit of spread in the upper exceedance probabilities. You'll notice that this 50% line isn't in the center of this distribution at all, right? So if we do exceed this 50%, that's good news, because that's going to be substantially more bang for our buck, probably. If we get up to our 70% chance, it's going to be quite a bit more water. It'll be well above. So fingers crossed for that. Marching downstream to the Guaymas River at Montezuma. This is a smaller creek. It's a feeder creek, though, into the Pecos. But this one is slightly above average in terms of forecast. Really not significantly so, but right there. So that's good news. Then here at the Pecos River near Anton Chico, we're kind of hovering right around average at this point. And then finally, the Pecos River near Santa Rosa, We're a little bit more optimistic that we're going to see more water than the NRCSs at this point. And this is slightly above average through most of this area. Again, all 4 of those points have that skew where if we do better than the 50% forecast, we're going to do probably pretty well in terms of volume. And that is pretty much all I've got for the outlook. I'll be happy to take any questions.
So again, if you have questions online, just type them in. Any questions in the room? Okay. We're gonna,
Can you?
Oh.
This is Carl with the NRCS. Sorry, I couldn't raise my hand in the way it's structured. I just one comment on some of these forecasts in the Pecos, and particularly this most downstream one at Santa Rosa. We've been talking with Chris Lander and his team at the West Gulf RFC, and it did come to light that we are currently forecasting strictly observed flows, and they are including more diversion data and stuff like that. So we're working with them, and we're trying to come to some congruence on that front. But I figured I'd just at least make that quick note on the divergence between the 2 agencies' forecasts, particularly at Santa Rosa there.
Yeah, particularly, you're absolutely. Sorry, continue.
Oh yeah, no, that was about it. But yeah, that just recently kind of came to light in our last meeting, and we've been working with Chris and his team to try and kind of come together there. But they are using some different naturalized stream flow adjustments, so that probably helps. I just figured I'd let folks know that that's part of the reason, I think, between the bigger diversion at Santa Rosa compared to some of the upstream points.
Yeah, he's absolutely right about that. The way that our water model works here with the Weather Service is that we are modeling natural flow. We are modeling what would go through there if nothing was getting taken out. And that's not the case at Santa Rosa. So we are, as a consequence, higher than the NRCS. This is true throughout the state. And there are a couple of points like on the Rio Grande where this difference is very, very extreme. And I think it's probably wise to recommend that you lean towards the observed flows from the NRCS at points like this, where there are quite a bit of diversions through there. The forecasts that we're showing up at the Pecos headwaters and Gainas, those are, you can be a little bit more confident. And in fact, the agreement with the NRCS is pretty good at those points. So thank you for pointing that out. I meant to touch on that. I appreciate you catching that one, Carl. Thank you.
Great, thank you so much. We're going to switch to Reclamation, and Eric Joseph is going to present the annual operating plan.
All right, that's coming in clear. All right, hello everybody, good afternoon. My name is Eric Joseph. I'm a hydrologist with Reclamation. We will be giving this presentation with USA Army Corps of Engineers. I'm going to be presenting their half today as well. So just a quick overview of the basin. Starting on the right at the top, looking at the headwaters of the main stem of the Pecos River, going down to Santa Rosa Dam, followed by Sumner Dam, Fort Sumner Irrigation District, followed by Brantley Dam, Avalon Dam, and then Carlsbad Irrigation District. I'm sure everyone's familiar with basin and the facilities here. Just talking about the owner-operators of each one of these facilities. Santa Rosa is a U.S. Army Corps of Engineers facility that's authorized for water supply, recreation, and flood control. Sumner is a reclamation facility, also authorized for water supply, recreation, flood control. There's the Two Rivers Dam, which is operated by the Army Corps for flood control purpose, and Brantley Dam, which is a reclamation facility, water supply, recreation, flood control, followed by Avalon, which is the last facility we'll be talking about, which is a reclamation facility authorized for water supply only. Just a few of the key terms we're going to be talking about. A hydrograph is a graph of flow rate over time. When we're talking about stream flow, we're going to be in units of cubic feet per second. And at reservoirs, we're beginning talking about acre feet, which is the volume of water needed to cover 1 acre to a depth of 1 foot. We have runoff forecasts, which are predicted stream flow volumes for March through July. This is provided by the NRCS, and a lot of this is based on SNOTEL or snow telemetry network composed of automated data collection sites located in the upper basin. We've already talked quite a bit about that. The model forecasts are based on the volume forecast from the NRCS. As discussed, this is based on snowpack, soil moisture, and other stream flow antecedent conditions. We select a similar year based on a similar volume or expected runoff, and we'll adjust the shape of the hydrograph based on the volume delivered by the NRCS forecast. We can alter these hydrographs to better match predicted flow conditions, and also the hydrographs are based on policy restrictions, flood control, channel capacity, the timing of water deliveries, as well as the demand plans for water users and historical data. This is just a quick overview of how the model is structured. We get a NRCS volume forecast from March through July. We use that in conjunction with hydrographs from a selected year, and we'll adjust the volume during that period to match the forecast from the NRCS. And that's the hydrographs that you're going to be seeing with their relative exceedance probabilities. Before we go into this year, we're just going to do a quick review of last year's AOP and the observed conditions. So for all of these, you're going to see a similar volume and a little bit of variability in the timing of that delivery, which is going to be based on conditions throughout the year. For Santa Rosa, one of the key things to point out is this increase in observed data related to some rain events that occurred during the spring. This resulted in some early increase in storage compared to our model prediction. I should have pointed out that our observed data is this red line, and the 50% forecast from last year is going to be the blue line. So this is the 50% probability of exceedance. So we did exceed that in the early part of the year, and then brought it back down to what we were expecting. At Sumner, there's a similar trend, as we had some temporary storage at the beginning of the year, and then reduced that throughout the year to our expected outlook. Below on the dashed line, you're going to see the minimum pool for Sumner. Moving down to Brantley, there's a similar trend. This one matched our prediction pretty well. And at Avalon, there was the lake was drained at the latter part of the previous year for a sediment survey, and there's a little bit more variability in terms of the timing of the releases, but the overall volume also matched our prediction of the 50% exceedance probability. So transitioning into this year and our current snow conditions, we've already covered quite a bit of this, so I'm going to move quickly through these slides. This is just the current outlook of snow conditions, and then on the right is the same snow water equivalent from the Pecos headwaters. I have 3 years selected here. We've already seen the black line. Unfortunately, the 2 purple lines are very close in color. The higher one is going to be last year, and then the lower is going to be 2003, which is the year that we ran our forecast off of based on similar snow conditions for that year. Now we're just looking at the expected volume and exceedance probability for each of the headwater gauges, the major tributaries to the Pecos. You can see for most of these sites, for the top at the Pecos River at Pecos, we're looking at near median flows, maybe a bit higher. We've already covered a lot of this information, where the general outlook for the year is median flow volume, maybe a little bit higher, and not quite as much as last year, but close to median. On the right is just the current hydrograph from the USGS gauge, Pecos River above Santa Rosa, and just a comparison with last year's discharge. So moving to our projected water operations for the year. Just a little bit about the graphs that you're going to be seeing. So we have 5 forecast runs, and these are going to be displayed in bands based on exceedance. So the purple line is going to be our 50% most likely probability of exceedance. Up until about April 7th, you're going to see current data. And then after that, you're going to see a purple band, which is going to indicate the 30 to 70% exceedance probability, and then a tan line outside of that, which is going to show the 10 to 90% exceedance probability. We've already talked a bit about exceedance, but a 50% exceedance probability is just going to be a 50% chance of exceeding the purple line here. So our first site is going to be the inflow to Santa Rosa. One thing to point out is that in a typical year, we'll see some rain events at this gauge that can produce high peak flow values even during our runoff operations. We removed those events from this hydrograph to give you an overall display of what we predict for snowmelt runoff. And so the purple line is going to be our 50% most probable. To the right, you will see some monsoon events, which are not part of the AOP forecast, but these are what we would call a typical, or at least what we observed for monsoon in 2003, or the type of event that could occur at this site. Moving down to storage, we're looking at a minimum exceedance of about 1,000 acre-feet here, peaking around early June. And we're forecasting a single block release in June based on all the inflow and comparing to previous years, with a range of flow within this tan band based on 10 to 90% exceedance. Moving down to Sumner, you can see the most probable exceedance for storage at the reservoir, and then also the predicted outflow. In the middle there, you can see the block release passing through Sumner, and then the other normal releases there projected for the year. And a little bit about the 2024 Supplemental Water Use Plan. We're expecting normal conditions under the biological opinion. The supplemental water supply at Sumner would be 4,500 to 5,000 acre-feet. Bypass availability is early irrigation season and based on runoff. And the Vaughn Conservation Pipeline is at 3,974 acre-feet. We target flows when bypass is available from April through October based at 35 CFS at the Pecos River below Tyband Creek near Fort Sumner. And there's the USGS gauge numbers, as well as 5 CFS at Pecos River near Acme. So looking at the Acme gauge flow forecast, you're going to see the normal flow conditions throughout the year. You'll see the block release moving through in June. And then also, this was the monsoon event that was observed there in 2003 that could indicate some of the summer monsoon flows. Our most critical time is here during the midsummer for targeting flows at this gauge. And moving down to Brantley, this is storage based on incoming inflow projected throughout the year. You can see the 10 to 90% exceedance band is going to give you that full range, where the others are closely matching our 50% exceedance probability. The Brantley outflow, again, has more variability, but the overall volumes are similar in terms of the release at Brantley for the year. And then for irrigation supply, we're expecting a full FSID entitlement by May to June. And then throughout the rest of the year, this is going to be more based on what type of monsoon we have for the year, as well as for CID allotment. FSID did begin their season on February 21st, and the initial allocation of 1.5 feet for CID began on March 31st. Pretty quickly. Would anybody have any questions? It's the end of my slides.
Derek, any questions from the room? Yeah, online, any questions that you want to type in? Okay, well, thank you so much for attending today. We will be posting this online and it'll be available. So if someone had wanted to attend and wasn't able to, or if you wanted to go back and review something, you'll be able to do that. And if you have any questions that come up later after we close this session out, you can email any of us and we will work to get you answers and get back to you as quickly as possible. Okay, well, thank you again, and we will do this again next year.